no fancy video at the beginning. I just have a massive photo of me, which is nowhere near as good. So, nor do I have anything as cool to talk about. So, but this is me, for those who haven't met me, which is highly likely. I don't think many of in this room will have done. I'm Jake Taylor. I'm a chartered engineer, registered with the IMEC. I've been with Technia, which was Intrinsis, previously for 10 years now, coming up in January next year, where I started as a design engineer and effectively sort of worked my way through to now lead the team that Craig so nicely described. It is definitely a team effort, and I couldn't do it without them, so I'll get that in advance. A bit about me: I have 2 daughters. I love sport, and I love obviously being an engineer. I love solving technical problems. So that's a bit about me. Why is it relevant? It's not. It's just to break the ice a little bit and get to know me. The most relevant bit for you guys is that, as Craig said, I'm the manager of the team, the design simulation team in the UK. So why do we have a team in the UK? As I said before, maybe you're not aware of the fact that we do have a team. We're hidden away in the deepest, darkest depths of our offices, and no one ever gets to say, no, that's a joke. It's not dark because we're engineers who know how to work the lights. That's right. In all seriousness, you might not be aware of the fact that we have a team based around this design and simulation expertise, so I always describe it as, instead of being able solely to support the product, we're at the coalface using it. That's the sort of historical legacy of the team, is that we do real projects using the solutions that we sell. We tend to find that is... Oh, excuse me, sorry. Pressing too many buttons. We tend to find... I can't scroll down, sorry. Where's my mouse gone? If only there was a technical team that knew how to work technical stuff. Oh, there we go. So we tend to find we utilise this support over 4 main areas within the team. So helping our CATIA or Simulia help desks with support from instances, obviously because we're using the software day in, day out. Delivering bespoke training potentially, so things like geometric dimensioning and tolerancing we support, composites training, Python scripting, and linear dynamics courses, things like that, so quite diverse. Providing technical resource and support for our pre-sales team, so they get the help they need for getting the right value for the product to our customers. And probably the majority of our work is delivering projects via consultancy work for a wide range of customer base. So how can we help? You'll likely be familiar with a simple sort of linear life cycle process like this. As we've seen, other people have used something similar, taking an idea right the way through to manufacture. And as Technia will attest to, as well as I, is that we can offer support across this entire life cycle and to different depths depending on what sort of support you require. I haven't told our marketing team this yet, but everyone loves an acronym, so I've called ours ESP, which isn't electronic shock protection, for those of you that are old enough to remember that, but is instead enable, support, provide, as I've put it down in here. So basically within the team, what we try and support is, do you have capacity, capability or software to do what you need to do? If you have the skill set and the capacity to do that, and maybe you're lacking the software to do that or some tool set that you need, that's where our sales team will come in, and we can support that and we can drive that and help you develop your own solutions. If you have the software and you have the capacity but perhaps not the skill set, that's where we can support. We have our training teams, we can do mentoring days and things like that to help utilise the software to its fullest extent, or help with strategic simulation and things. Or perhaps you have the skills, you have a team, and you have the software and the tool sets, but actually you've got another project that's come on board and you don't have the capacity. That's where we can be an extension of the team and just drop engineers in place straight away to help out by just providing more resource. And that can be anything from a couple of days of, oh, I need someone to help out and finish off some surfacing models, to 10 months worth of full turnkey solutions. I once saw an interesting graphic that was effectively this unit from sort of describing services as a class system. I think, I can't remember where I stole it from, but I definitely stole it from someone else, so I'll try and find out who to give their credit. So the first class is obviously what I was describing before, with the idea of supporting that development and supporting you. What happens next? What happens if you have a skill set, if you have the capacity to do this job and you have the software? What do you do next? And it's part and parcel really of why we're here today, and what we're trying to achieve, and what we try and achieve through the team is actually taking it up a level. What's next? how do you get to that second class, that class 2 level, where you can automate your workflows, where you can use digitisation to increase your efficiency, and that's where our engineering consultancy can potentially help as well, because we have people using that software, we have people that have gone through those processes, and a lot of transferable skills across different industries and customer base. So our journey, it's going to sound a little bit like a sales pitch, I guess, as it has done already. Apologies for that. I guess it kind of is in one way, shape or form. But this sort of methodology, one thing we went through with our team, bearing in mind that there were some acquisitions, some growth and things like that through Technia as a company, there was a small change in direction of our team as well, in the fact that historically we had a team that was built around design capability, historically we had a team built around simulation capability, and in coming together as part of Technia and a bigger organisation, we merged those two teams to make sure we had an integrated engineering approach effectively. This was effectively to avoid trying to be siloed, really, try and make sure that actually we're effectively trying to preach this methodology to other people and ensure that people think about the process that they take on board. But in doing so, we took it on board ourselves and found a lot of benefits going through that journey as we would pushing it out. So we now try and look at the idea of bringing in the same sort of inputs that everyone would bring in from their customer projects. Only obviously our customer projects are potentially you guys. We don't actually manufacture anything ourselves. Bringing those on board and supporting with the ideation stage, and then integrating that approach through design, through simulation, through process development, helping with anything towards the output being a manufacturable product. Whether you need advanced simulation or just some drawings doing or things like that, let's integrate that approach and make sure that the engineers are overlapped and they can all support in the same sort of areas, rather than having that wall where and silos where someone finishes something, chucks it over, and someone else finishes it and sends it back, and the communication potentially and the data gets lost. So as a very sort of quick roundup, I wanted to try and show an example of something we've done. A typical project for us is quite difficult, as you can imagine. Being a DASO provider, there's quite a range of industries, there's quite a range of customers. We support quite a few different people, so it's difficult to come up with a typical project. One of the most pertinent works probably that we've done lately is this image here, which hopefully doesn't make any sense. It's not supposed to. Unfortunately, this customer we've been working with for quite a few months now are developing a product and they're launching this next month, and asked us not to show anything in context, so we have luckily been allowed to take it out of context, and hopefully it doesn't make any sense. Please don't say if it does. But what I can say about this is that it is a real part. We have gone through some development of this. We have, and as you'll see, some photos of things come up. This has been manufactured now as well, which is always cool for engineers. And the reason this is relevant is because it brings together what I was trying to describe about these two disciplines. Is starting off from a design perspective, we took this component from the design team at our customer's site basically, and it was relatively well controlled, sort of quite tightly on the outside of what the whole thing could look like, and the fixing points of where it was mounted, and the overall look and styling of the unit was quite well controlled. So we had to utilise our sort of CATIA skill set to build up a surfacing creation and make the product look how they wanted it to look, but also try and make the thing work, of course, which is paramount. So scenario effectively is that we tried to take this through an integrated process. We tried to build up our scenario as it would be in situ, and there's a few other potentially some components missing here. So we wanted to build this into the platform as simply as possible and empower the designers that were working on this to go through that iterative loop of design and simulation and make sure that what they were getting out the end was going to be suitable to the functional spec. So the component itself is effectively a main beam structure, front to rear. There's fixings on the blue arrows. It's allowed to freely rotate around the green arrow. There's some load where the red arrow shows, and there's a fixing point where the orange ones are shown. And we obviously wanted to put that load case in with some some safety factors and make sure that that this thing was going to survive effectively. So we added these boundary conditions in, run it through the platform, run it through its initial simulation, and first off, unfortunately found that because of the shape of this unit, as I said, was relatively well controlled, we actually found that where you can see those yellow arrows there, that the unit was bowing inwards. There was a lot of deflection in that area as this unit was trying to rotate and lift the mass that it was lifting. So we built that back into the design process to have a look through, to go back through a small review and see what else we could do to make some small changes to this. So the first iteration of this was that instead of just trying to fix at the front and rear, we tried to add a couple of fixings in the middle, maybe just to react to that deflection and make sure that we were transferring the load path somewhere else. In doing so, we rerun the simulation. We added these fixings to the centre point, and you can see that from the red spots in there, red is bad, as someone said earlier, blue is good, if no one's noticed that, so only a small red area, which is, I guess, relatively good. But here, with an aluminium casting, this part could yield, which means it deforms, which means it doesn't work. What we wanted to do, obviously, was migrate that path as we have done in this area. So although we've now moved that point of load and moved that high sort of stress area across to this fixing, it's still not ideal because it's still failing. So we updated that, we put that back through the system, got the designers to make a couple of changes and built in, as you would, some stiffening ribs, some bigger blend radii and things like that to make sure that you haven't got stress concentrations and things on the component. And you can see it's obviously reduced slightly, but not perfectly because we still have some red areas. The one big advantage of this is this was all really quick to turn around. You'll see in a second that we went through about 4 iterations of changes, and this was over hours rather than days or weeks, because the whole control was built into the platform. The model was built in, the surfacing was created, the solid model was created, the mesh and everything was built into that using the Simulia products, and that was effectively then set up by one of our analysts to support the initial load creation and the boundary conditions, and then rerun by the designer. So the designer then effectively takes that item away. They can make their changes, they can see what they want to change and update, and then just rerun. And within a matter of, I think this was tens of minutes maximum, they've got an answer back. And of course the advantage of doing that and building that in early was that here, where you can see the angle of these ribs that are built in, they were specifically designed at that angle to ensure that the load vectors from the previous calculation are taken into account from the main loads of the unit. So another small assessment, and again, rather than just go into the sort of full-on engineering of the component, it's more about the process of what's happened. It's building that back through and ensuring that the iterative cycle is quick and is easy and is informative to the designer, the engineer that's working through that, to empower them to make more decisions effectively. So you can see from the last iteration here that the stress levels have dropped considerably. They already had a factory of safety built in as well, so they had to sign off by the customer, and we managed to get them to go away and make something, which was good. So again, as I said before, having these built in, having these load cases built into the native geometry, the parametric geometry, allows you to make those changes. We can see how having them built in is an advantage because it's nice and quick to make another round of results. As I said, in this case, the initial run was set up with support from an analyst, but the further ones can then be run and support by the design engineers themselves, unless they need to obviously need to call on some further support. But what is most pleasing, as I said, is that we now have a real part that was made. I think this photo was taken last week, and my OCD hurts slightly because it's not in the right orientation, but I'll get over it. So I think that the metrics attached to this is a soundcast component. The tooling for this was, I believe, about £15,000. Now, that's not a lot for tooling. For larger scale, larger volume, you could be talking up to £100,000 for different style. But 15,000 is still a relative outlay for someone. This is a very sort of relatively new startup with investment. We turned around a few changes in that in a couple of days to make sure that we hadn't missed some of those. And admittedly, without going into all the detail of the design itself, some of those would have been captured doing proper design reviews, and people would have noticed there's stress concentration areas, and people would have said, oh, that's a typical issue, and you would have picked some of those up. But actually having that capability to very, very quickly come up with an answer and show that in reviews and change the design accordingly meant that instead of going to print, for lack of a better word, on a £15,000 tool that then didn't work, within a day or so, we'd made a decision, everything had changed, and we've now gone to a component that is fully functional. So even discounting the sort of efficiency, the time and everything that's taken into account, there's obviously a monetary gain there as well, or saving rather than gain potentially. So the integrated approach we're using, obviously we're trying to suggest to people it's got good methods. There's a lot of positives about this. We've seen some example cases, obviously, in various situations where we've utilised this integrated approach and we've saved time or money on a part, as we showed back there. But how can it help you potentially, or how can we help you maybe? So one of the two main ones I've found in going through this and over the last year or so in integrating our teams is that having the design software available for analysts was a massive benefit. We had an instance where one of our analysts was defeaturing and pre-processing a model that used to take hours in the software they were using just because it wasn't cut out for modelling. We were able to turn that around using Technia in about an hour or so. So it was effectively a cheaper piece of software for less time with a potentially cheaper resource. So integrating there had a massive saving and theoretically what's not to like. The second point we found from this is that it gives the analysts sometimes some access to that, so they can potentially go through that or help out and blur those lines potentially between the two to overlap, so that both are learning from the other area rather than having those siloed roles. The other option potentially, as well as empowerment, is giving the design engineer some exposure to the simulation they're getting involved in. Probably too often in the past it was a case of someone would design something, they'd finish it, they'd throw it over the fence, and an analyst would analyse it and send it back and say it didn't work, or hopefully it did perhaps. But in understanding the process and the designer seeing that and perhaps understanding that they can't just push everything through with every little fillet and radii on because it takes ages to process. You need to defeature things, you need to understand how to set up models before they get run. That gives them a little bit more understanding, gives them empowerment to either do it themselves or help out in future or foresee some of these issues and actually take out some of that sort of time that goes in and increase that efficiency. That was also a massive benefit from what we've seen. So, and of course, the longer that goes on, the more involvement they get, the more chance they've got to overlap, and the more they can run themselves, hopefully, and pick up on some knowledge each. So, yeah, very quickly in summary, of course, there's hopefully a lot to consider, potentially, from what we as a team or we as a company have supported or done and what we've integrated. I'm obviously not suggesting that anyone should be forced into a certain approach. We're merely just trying to suggest that we changed our methodology very slightly, integrated our team, and we found many more benefits than we have negatives in that area. Just a small shift in that mentality was a real positive. And we are still able, or now able, effectively to output what feels like a full life cycle on a product much more quickly, using, I'll say again, as someone said earlier, the power of a platform is always nice. So it was very beneficial to us. It was really useful. It was nice to have that overlap. Every engineer's picking up more information. We're getting involved in more and more projects. Hopefully there's something on there potentially that you may not have seen before, and if there's any instance where you believe we might be able to assist, if you just need time, resource or expertise in certain areas, then please give us a shout. Myself and my colleagues are obviously out in the foyer again afterwards, so if anyone has any questions then please feel free or come and see us afterwards. So, thank you very much.